We have here the 2022-2023 end of semester exam for OOP or OP1. Let's start by doing section A. Section A requires us to fill in the blanks with the words or keywords that are required. So dash is a method that has the same name as the class where it is defined and has no return type. So this is a constructor, and a constructor let's demonstrate that with section A 2022 2023. So let's create a simple class called A, and any method that has the same name as the class and returns nothing is what we call a constructor. So this is a method defined like this. It has the same name as the class and it returns nothing. So there's no return type like void or int or anything. It's just like that. So this is what they call a constructor. So A is the constructor, B is to define a class. To define a class variable, we use the keyword dash. So what is a class variable? Class variables are variables that belong to the class. So we define a class variable using the keyword static. So if we take this same class, we can have a static variable like string name, like that. So this becomes a class variable. This variable name it becomes a class variable with the keyword static. C is every class in Java has a superclass except. So all classes in Java are derived from the object class. So all classes implicitly extend this object class. So you can see when we hover over this custom class, we see class A explicitly extends java.lang.object. So IntelliJ is prompting us to remove this redundant extends object because it already implicitly does it for us. So we can always get rid of it like that. But if we keep it there, it still causes no issues because all classes extend the object as the root. So you can see as we dig down into this object class, you can see from the documentation that class object is the root of the class hierarchy. So every class has object as a superclass by default. D is dash is a keyword used to indicate that a class is related to another through inheritance. So how do you demonstrate inheritance in Java? You use the extends keyword. So A extends object. This is inheritance. So D is extends is a keyword used to indicate that a class is related to another through inheritance. Part E is dash is a keyword in Java used to create objects of a class. So how do we create objects of a class? Take this class A. How can we create objects of class A? We do that using a keyword called new. So this is how you can create objects of class A using the new keyword. So new is a keyword in Java used to create objects of a class. Part F is dash is called an incomplete class, and such a class can't be instantiated. What are incomplete classes? Incomplete classes are abstract classes. So if you have a class called abstract, to make it incomplete, you have to use the keyword abstract. So this becomes an incomplete class, and such a class cannot be instantiated. That's the extra bit of information, this one. A class can't be instantiated. This incomplete class can't be instantiated. You can demonstrate that by creating a main method and trying to instantiate the abstract class using the new keyword like this. Oh, we can't use the keyword abstract as a variable. So let's just use object like that. So this is impossible. Abstract is abstract, cannot be instantiated. So we cannot do it. We cannot instantiate abstract classes. Then we go to part. So this keyword here is abstract. Okay, not okay, yeah, it's a set of words, abstract class. So abstract class is called an incomplete class, and such a class can't be instantiated. G dash is a keyword put between a class name and an interface name when the class has definitions of the methods of the interface. Okay, so interfaces and classes. What keyword is here? What keyword is put between a class name and an interface name? That keyword is called implements. So if we have a random class B and we have some interfaces down here, interface A, and we have interface B. Why are you complaining? Okay, let's call it IA and IB for interface A, interface B. So the word we are looking for, which word is put between the class name, which is B, and an interface? So you have like an interface here. Which word is put in between these two? So that keyword is called implements, because classes implement interfaces. So you can implement multiple interfaces by using comma and another interface name like that. So we have this class B implementing interface A and interface B. But the keyword we are looking for is implements. So implements is a keyword put between a class name and an interface name when the class has definitions of the methods of the interface. H dash is a keyword put after the visibility modifier to indicate that the class cannot have subclasses. So to make sure a class cannot have subclasses, we use the final keyword just after the visibility modifier. So this final class cannot have subclasses. What do we mean by that? We mean if I have a class, another class like AB, this class cannot extend a final class. So it cannot extend B like this. This won't compile, it's causing an error here. It is saying you cannot inherit from a final class. So if you don't want this class to be inherited, you just have to make it final. So that's the keyword we are looking for. Final is the keyword put after the visibility modifier to indicate that the class cannot have subclasses. Move to I. When using scanner class from Java.util package, Dash is the default input stream that the scanner object uses to read user input from the keyboard. So they are looking for the input stream that the scanner object uses to read input from the keyboard. What kind of input stream is that? Okay, so we can demonstrate this using a new class called scanMe. So in the main method, we can have a scanner called scanner, and this scanner takes, inside here is where you put the input stream. So the input stream it's going to take is called system.in. That's the input stream, as you can see here. With the IntelliJ, it is saying this is of type input stream, like that. So the input stream is system.in, and we are going to use this scanner object, like this scanner object, and you use the methods on the scanner object. Next int for integers, next line for strings. So let's use the next line for strings and pick a string, and then we are going to store this string in a variable called s, like that. And then we are going to demonstrate something else, system.out. I'm going to demonstrate this print stream for printing out on the keyboard. Print ln, like that. Yes. Oh, sorry. Yeah, we already had it here. So we are going to pick to read something from the keyboard using this input stream, and then output it using this output stream, this one, system.out. So the input stream used by the scanner is this. So this is the word we are, or a set of words that we are required to use, system.in. You have to make sure it's capital S, because the system class is capital S. So if I run this, it will prompt me, not prompt, it will allow me to input something in the keyboard. So it will pick, we are causing some errors here. Okay. So let's make sure these don't cause errors, so our code can run. Let's run it again. So I'll be able to input something from the keyboard, and then whatever I have outputted will be spit out again using this. So here I can say hello Java devs, and when I press enter, it is then again spit out for me like this using this kind of code. So that's what scanner is normally used for. You have to use this input stream called system.in, which is what they are looking for here. When using the scanner class from the java.util package, which is this util package here, java.util package, dash is the default input stream that the scanner object uses to read user input from the keyboard. So this is the input stream they're looking for, this system.in. So that's what you have to type in here, or rather write as your answer. But it must be capital S and small I, small n. So we go to J. During method overloading, dash is a term used to uniquely identify each of the versions of the method that has been overloaded. So to answer J, we must understand what overloading is. Let's say overloading. So overloading is when you have multiple methods with the same name but different signatures. So by signature, I mean whatever is between the brackets. So here we have a method called add, and if we want to overload it, doing it like this will cause an error, because now we have two methods with the same name and the same what? The same signature, but we must make sure that the signature here is different so that we can demonstrate what? Method overloading. So if I put a different parameter inside the brackets, then the error goes away and we have demonstrated what? Method overloading. But it doesn't have to be just one single parameter. So you can have like different parameters. For example, you can have an integer x and an integer y, like that. This is also method overloading, because the method name is still the same, but the definition here, the signature here, not the definition, the signature here is different, which makes it overloading. But you can also have public void add. You can also have one parameter but of a different type, like this, because here we had one parameter but its type is an integer, and here we have another parameter and its type is a string. So these are two different signatures. So this becomes, it is also valid what? Overloading. Valid method overloading. So that's what it is basically. All you have to remember is everything stays the same, but the signature has to change. Only the signature changes here. But they could trick us and do something like public int add, and then something like int x, int y, int z. So this is also method overloading, because it doesn't matter what you have before the method name. See, here we have void, 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 and here we are returning an int. So here we have an error because we are missing a return statement. So we can return an int like this, and the error goes away. But this is still valid what? Method overloading, because remember, all that matters in overloading is the what? The signature here, and here the signature is different to all these ones above. Because you see here we have int x, int y. So if we take away this int z, it's going to complain and say we have what? We are not demonstrating overloading here. So when we try to hover, here it says add int is already defined in overloading. So it is saying we have already defined this method here above, and even though we are returning instead of returning nothing here, we are returning an int, you're still saying you still have the same what? The same method name and the same what? The same parameters. So to avoid that, you have to make sure that the parameters you have here are always what? Different. Because that's what method overloading looks for, different parameters. So during method overloading, a method signature is a term, or rather during method overloading, method signature is a term used to uniquely identify each of the versions of the method that has been overloaded. So these are the different what? Method signatures. Here we have nothing, here we have one int x, here we have two integer parameters, here we have one string, here we have three integer parameters. So these are the signatures here inside the brackets. So these are the method signatures. The method signatures have to be different, but with what? The same method name. And it doesn't matter what the return type is here. It also doesn't matter if this is private or protected or package default, as long as this is the same and the parameters here are different, that is valid what? Overloading. So we can have here private, we can have protected, it will still compile nicely. You can have package default like that. This is all still valid what? Method overloading. So here the words you're looking for are method signature. So during method overloading, method signature is a term used to uniquely identify each of the versions of the method that has been overloaded. So let's go to part 2. Part 2 says copy and complete the table below as far as visibility modifiers in Java are concerned by putting a tick where visibility is possible and an X where visibility is not possible. So we have one column with the modifiers, another column where we have to put the tick or the cross. So let's start with this column and this row where we have the default modifier, visibility modifier. So let's do this with code. We have a class called visibility, and accessible within that class where it is defined. So let's try defining a string called name, and let's have a main method where we create an object of type visibility like that. So can we access this object, this property here, the name property, using our object? Yes, we can, because running this should give us the value now, not a value, but yeah, nothing, should give us nothing. So it gives us now, because here our name is not set to anything, so by default it's set to now. So we can access this private field even though it's defined as private. So this becomes a, hey, wait we are doing default. So package default is like this. It's like this, package default, like this, but we don't have to write the actual name. To make something package default, you have to just eliminate the modifier like this, and then it becomes package default. So when you're in package default, can you access the field or the method in that class where it is defined? The answer is yes, because when we run this, we should still get null. So that's package default. So this is a tick. What happens if it is private? So if it is private, we still can access it. Private string name. Run that, it should still be accessible because we are not seeing any errors here. So we should still get now. We still get now. So tick. What if it's protected? If it's protected, we still get now. It still runs because protected applies to everything within that class, and it's subclasses. So everything within the class is accessible. So when we run that, we still get the null value. So here we have tick and tick. So what happens if we have a subclass and we try to access any fields with these modifiers? So let's put some extra space, and let's create a subclass called another, and this subclass is going to extend visibility like that, and we're going to try to access it's another is equal to objects. We're going to try to access this field here. First, when it is what? Default. So let's get rid of the protected. So if it's default, package default, we should be able to access this field because we are dealing with stuff within the same what? The same package here. So we have another dot name like that. So you see we can access it. So if I try to print it out like this, and let me just have a different input like another equals something like that, so you don't mistake it for this. So if I try to run this, I should get another equals null. So let's move this to the right top like that. So this is when it is default, package default, and we are in a what? A subclass. So here, accessible in the subclass default, yes, we can access in the subclass. What if it's private? If it's private, then we cannot access in the subclass because private fields only belong to the what? To that class. So anything outside, we cannot access the name. As you can see here, we're already getting an error. So if we try to run this, of course, it won't run. So Java here, it's giving us name has private access in what? In visibility, meaning we cannot access it from anywhere else. So meaning here we get what? A cross. Here it was a tick. Here we get a what? A cross. But what happens when it is not private but protected? This, as I said earlier, will run because protected applies to that class and its subclasses. So this class, whatever is in this class, can access the protected field, and whatever and the subclasses can also what? Access the protected field, as you can see here. This is not causing an error. So when we run, we should still get another equals to what? Another is equal to null. Like that. So we have tick, cross, and tick. But what happens when we try to access this field with these modifiers in another class, but within the same what? The same package. So we have here the same package, but let's create another class. Another class, not within the same file actually, just another class, another different class. Let's call this class different. So different has a main method, and different has a different object. And this different object is what we are going to try to use to access the name field. We are trying to access the name field on this field of the visibility class. So doing this, like we have been doing before, yields a what? An error, because we are in another class, but still in the same package. And the visibility here, at first it is saying we should test for what? For default visibility. This one, default. And to make something default, we just remove the modifier there. So if it is like this, here we don't get this resolved, it becomes an error. So running this, of course, gives us an error like that. It's actually saying we cannot find whatever you're referring to. They can't see it, even though it's in the same package, but they can't see what name is. So this is an X. What happens if it's private? Now this one we should all know already, that when something is private, only belongs to the what? To that class. Nowhere else can see. So here so this becomes still, it's an error, so it's red, so you still cannot access. So this is what? An X. What if it was protected? Protected applies when you have the class itself and its subclasses, and whichever class inherits what? This class can access the what? The protected field. But this class here is different, like it doesn't even inherit the what? The visibility class by extending it like this. So it's just some different class in the same package. And we can see here, we cannot access the what? The name field on visibility because it's protected, and these two are different what? Classes. So this also becomes a what? An X. So we have X, X, and X in this column. And that's part 2 demonstrated. Let's go to part 3. Let's first get rid of these errors. So when we run something, nothing breaks. So part 3 is saying, using an example of your choice, use Java programs to demonstrate each of the following object-oriented programming concepts. No mark shall be awarded for any explanation or definition given in this question. So don't explain, don't try to do anything, but write code. Just write your code. Only the code is required, and you must number your work properly by clearly indicating the concept you are demonstrating at the top of the program. Okay. So part 3 is we're going to demonstrate these following concepts using code. And the first concept is constructor overloading. And in brackets, they're telling us to make use of the overloaded constructors. So let's do some constructor overloading. And overloading. Can we choose class? What is this? Oh, we already have overloading. Okay. Let's shorten it to constructor overloading like that. So, okay, so it is imperative that when attempting these questions, you use simpler examples. Don't over demonstrate things. The code might get too bloated, you might get lost. So let's use a very simple property or field called name, and then you're going to create a constructor. Remember, it's created using a modifier and the same class name like that, and you have a field, not a field, and you have the brackets and then a body. So that's our constructor, and this constructor is going to set this name here. We're going to set that name to Terry like that. Now remember what we said about overloading. Something up here. This one. During method overloading, dash is a term used to uniquely identify each of the versions of the method that has been overloaded. So this is applying to method overloading, but the same concept still applies for what? For constructor overloading, because you just have to change the signature. In this case, the constructor signature. So here we have this signature taking nothing. So if you want to overload that constructor, you just have to say CO, and then inside the brackets we need to have something different, and in this case we are having string S like that. Now what this constructor is going to do, basically a constructor is like a constructor constructs objects. Constructor is used to construct objects. So this constructor here will be used to set this name here, this property, this field. We're going to set that name to whatever we have here, whatever we input, we as the user, whatever we input in this parameter is what will be used to set the what? The field up here. So let's try, because they said we should make use of the overloaded constructors. So you're going to make use of them using the main method. The main method is where you run your code. Let's create some extra space. So we are going to have the first constructor. This is the object. Object 1 is going to be a new constructor. This constructor, the first one that we had here, like that. Now this constructor is the same as this one, meaning this is the code that will run when we are creating our object. So here, once we have created our object, it has now set the name to what? To Terry, just by doing this. This has run, this code here has run, and it has set the name to Terry. So this name is now what? Terry, but only for this object. So if we try to print out the object, the name for this object, we should get Terry. If we try to run that, we should get Terry, because this is the code that ran when the constructor was used, because we used this constructor that has nothing. So you can see we have what? We have Terry. So what if we had a different constructor like this one? This overloaded constructor here is different from what we have above here. And you can see here IntelliJ is saying this one is unused. This constructor here is never used. So we only use this one. So let's use this one as well. So let's say object 2 is equal to, we are going to use a constructor. Remember, constructors are used to construct objects. So I'm going to use this constructor here, the one that takes a string. And what do we want to construct? We want to construct an object which has a name called what? Called John. So the moment we write this line of code here, this constructor is going to what? To run. So it's no longer saying it's unused, because now it's being used. It's saying here one usage. So this code has run, and when this code runs, it's going to say whatever is in here, which is John. Get John, which is now S. Get John and put John here in this name. So this name is now what? John, but only for this object. So if we print out the name associated with object 2, we should get John, not Terry. We should get John. So if we run this, first we should get Terry, and then we should get John. So we have Terry and John, and that is constructor overloading. So let's do method overriding. You do not have to call any method. Good. Okay. So let's get rid of that. Let's bring back our project. Now, in some earlier video I had done, I had mixed up these classes and did something like this. I created a class called override, like that, to demonstrate method overloading, which we are going to do. Method overriding, sorry. So what I'm going to do here is I'm going to create a method. Actually, let me create a default the method with the default modifier, method called one, like this, and this method prints out one, like that. So down here, overriding is associated with inheritance. So you have to inherit to override. So you're going to have a class called overridden, like this, overridden. And this class is going to extend our superclass called override, like that. Now, by extending this superclass, we need to override this method to demonstrate method overriding. So we have to use the annotation at override, like this. And Java is trying, and IntelliJ is trying to correct that for me, but I'm going to explain why it's correcting it like that. So we have our overridden method like this, and this is saying over. How do you spell overridden? Double D? I don't know. I think it's single. Overridden like that. Yes. Now, in the previous video I had done, it had a similar question like this one. I was perplexed as to why this was causing an error, because it should not. Now the reason is we have a class called override.java, and this class is clashing with this override annotation, because they have the same name. So that's why IntelliJ had previously done something like that, like this, because now it is saying this override, I think it's a class. Yes, this override class is gotten from the java.lang library, not our own library, not from here, because we also have an override here, .java file, but it is saying this annotation is gotten from this library, the java.lang library, not our own, not this library of our own that we've created. So that's why if we want to make it not cause an error when we use this, we have to rename, to refactor this Java file to something else. Like let's say this file should be custom override, like that. So this then becomes custom override, and this also becomes custom override, like that. And then the error disappears. This is overridden. Let's correct the name, like that, the class name. So this is why we can this is how we can get rid of the error that we had before, because we had clashing names here. These are called annotations. It's a kind of an advanced topic, and maybe in one of the future videos that I plan to do, I'll try to explain this further. So basically, you should always have your own custom files that do not mirror or do not look like any other custom Java files. That's why before, when I was trying to demonstrate the scanner, I didn't name this as scanner because it would clash with what? With Java's scanner. So if I rename this file as scanner, like this, errors will start popping up everywhere, like this. See? So Java won't know, like, it won't, because we are trying to use the scanner in the YouTube package. And yet, for me, I'm saying, no, this scanner of mine is the one I define in what? In my library, in my custom library here. So that's why it's imperative to always use different names, not the ones that are already in the Java, in the Java library. So let's revert this like that. Go back to our custom overriding. So if we go back to the question, method overriding says you do not have to call any method. Okay, so you don't have to call any of these methods that we defined and overridden. But let's try to do that anyway, because why not? So we can create a custom override object. We go to new custom override object, and then we are going to call this method here. So custom override.1 like that. So this should print 1 when we run it. And we can also create an overridden object called overridden like that, and then call 1 on the overridden object, which should print overridden. So we should have 1 and overridden like that. But this is not required, so we can get rid of it and stick to that. That's what is required for us to write in the paper. So that's method overriding. Let's look at method recursion. So as you can see, the questions are recurring. Like I had also done a previous video where I did the same. I answered the same questions. So method recursion, I'm going to try to demonstrate that using a class called recursion. So what we're going to do is, at first, let's define what recursion is. So recursion is calling the same method within within that very method. So I'm going to call the same method within itself. That's recursion. And to demonstrate this simply, I'm going to create a main method. And what I'm going to do is, before I create the main method, I need to create the method that will be called recursively. Public void recursive like that. So to make this a recursive call, all I have to do is call this very method within itself, and by doing that I am demonstrating what? Recursion. So basically just doing this should give us what? Should give us these marks. So your program should make a call to the recursive method and provide some output. Okay, let's provide some output. So if we say some output like this, okay. We need to create a main method so that we can run our code. So let's create a recursion object called recursion, and this recursion object is going to be an instance of recursion like that, and then we can call our recursive method, this one. So as you can see here, IntelliJ is saying this is a recursive call, because in this code, in the main method, because the main is where the code runs, when we call this method here, this method above, it will print some output, and then it will call the same method. It will call itself again. So when it calls itself again, it will still do this. It will print some output and then call itself again. So when it calls itself again, it prints some output because this is the method that is being called. And what it does is it prints some output and then calls itself again like this. So you can see it's an infinite loop. So basically, if we do this, we should get our 9 marks because this is recursion. We are demonstrating recursion. As you can see, when I try to run this, I should get some output, and then unfortunately our program will crash because we run out of memory at some point. So you could maybe take a look at this. So we have some output, and then program crashes. But the question didn't say don't make sure. Make sure your program doesn't crash. It just says demonstrate recursion. So for this, just for doing this, you should get your 9 marks. But since we are good Java devs, let's try to prevent this program from crashing. So what we are going to do is we are going to control this recursive call and make sure it only prints this maybe 3 times. Let's just go for 3 times. So we are going to say if this is conditional logic, right? Conditional statements. So if I is less than 3, that is when you should print some output. Now we need to make I a static field up here like this and set it to 0. So initially I is going to be 0, and then when we call this method, it should check if I is less than 3, which is true, and print out what? This. So it should give us some output, and then it will call itself again. But this does not prevent the program from crashing because it is still what? Infinite. So we need a way to control this execution. So we are going to say after printing out I, after printing out some output, increment I by what? By 1, like that, I plus plus. So what is going to happen is when we call our program, it is going to execute this block of code, and previously at the start I is 0, so is 0 less than 3? That is true, so print this out, and now 0 becomes what? Becomes 1. And then call the method again. So it calls the method again. Now what was 0 is now what? 1. Is 1 less than 3? Yes. Do this. Increment 1 to 2 and call the method again. So that is twice. So is 2 less than 3? This is true. Do this. Print out some output and increment 2 to what? To 3. And then call the method again. So it comes here. Is 3 less than 3? That is what? That is false. So if that is false, then it is still going to execute this recursive call. So we have to make sure that this recursive call is also within the what? Within the control block. So that it only happens when I is less than 3. So after when we run this this block of code, or rather when we run this program of ours which will execute this block of code, we should get some output 3 times. So running this should give us some output 3 times. So we get some output, and then yes, that. So this is possible because we made I static. And once we made I static, This meant that there's only one copy. There's only one copy of I in memory. This means that here, when this block of code runs, it will say, it will check if I is less than 3, and here is where it will modify this value of I. So this value of I, from 0, it will go to 1, and then 2. And then make this 3. Yes. So that is only possible because we made this static. But what happens if we remove the static keyword like that? Because my guess is that we should still run fine, because when this program is loaded into memory, this recursive call will be made, and this block of code should run. Remember, I is 0 here in our program. So when we increment it here, it should still increment fine, because it is outside, it is global. It should still increment fine. So if we run this, it should still get some output 3 times. So it doesn't matter if it is static or not, because if it is not static, then it ceases to be one copy of I in memory. So it's no longer that, it's no longer true. So you can just have something like that. And that is recursion demonstrated without any errors or without any program crashes. Okay, so that is recursion. Next is section B. Let's do those in different